Okay, good. It works well. So today is a review class for the first review class for second test. I posted 3 versions of sample tests. Okay, there are previous tests from last semester and last year, so that's a total 3. Okay. So in this class, I'm going to discuss. Today, I'm going to discuss the first version in the class, and I'm not able to discuss all the problems. And in the next class, if you do have questions, you can ask me in the class or online. After test, we're going to have final exam, right? So we have 1 week review. Okay, I hope you are able to attend my lecture. Now, I'm going to, if I recorded my lecture today, so if it's work well, I post it on YouTube, okay, so you can watch it again, okay? I'm not sure yet. So sometimes it's not good when it's right on screen, you know, then you hear the pens writing on the screen. Okay, it's not only just a voice. All right, so let's see. There are about 10 problems on this test. Okay. So it takes about 1 hour, 15 minutes. Okay, the first problem. You should understand the question clearly, right? So if I ask you to express the integral as a limit of a Riemann sums, and in this problem, I even said don't evaluate the limit. Okay, then don't evaluate. Don't waste time. Yeah, the time is the limit, right? So you don't need to evaluate the integral because I'm asking to express the integral as the limit of Riemann sums. So you have to see the Riemann sums in your solution. Okay, so that's the first question. Express the integral as a limit of a Riemann sums. Okay, so here's the integral from 0 to 1, x1 plus x squared dx. Now, when you see the integral, you say, oh, I can use a substitution to evaluate it. Okay, I don't want to see the answer. Okay, so don't do that. You know, sometimes I give you a function, you cannot evaluate the integral, use a substitution. But this one, yes, you can use a substitution to find. But I don't want it. Okay, of course you have to involve the natural log, but maybe you know something took a math 166 before, right? So, but I don't want to evaluate the integral. What they're going to do is to write down as a limit of a Riemann sum. Since this is a continuous function, so we can use sub-intervals of equal size. Okay, so this is by definition. Okay, this is going to be supposed to be the form is like that. It's just limit. Okay, limit is let me write down the general formula first. Then you try to fill the details. The general formula says that if you have this integral, this can be the limit as n approaches infinity. And this is the n, I from 1, and here fxi delta x. That's all I need. So you have f is given. The interval a from A to B is given, right? So the delta x is going to be b minus a divided by n, and the xi is going to be a plus I delta x. This is a complete formula for this. Okay, complete definition for the integral. Okay, so what happens? Then okay, I did not touch any place. Okay, so So now delta x for this particular problem is 1 minus 0 divided by n. It's 1 over n. Okay, and the xi is going to be 0 plus I delta x, right? So it's going to be I over n. That's it. And the function is given. So the integral from 0 to 1, x1 plus x squared dx is going to be limit as n approaches infinity. Okay, what is x? Xi, right? It's 1 over n and plus I over n squared, and the delta x is 1 over n. So that's it. Okay, so this is the answer. You don't need to even simplify, and that's it. So the second question is about the integrals. When you see integral like that, right, the natural idea is to use substitutions. The substitution method, right? I don't think there are any other method you can use here. The substitution is you have two choices. Let u to be cosine x or sine x. I think we should use cosine x. Okay, you know, you can try sine x. If it does not work, then you change it back to cosine x. Okay, and du equals negative sine x dx. So sine x dx, it would be negative du. So the integral is going to be integral here and u square, and then sine x dx is negative du. Okay. All right. So the antiderivative u square will be 1/3 u cubed, and don't forget the constant. This is a general antiderivative, most general antiderivative. Then cosine u is going to be cosine x. So that's the answer. I don't see there any other methods you can use here. Okay. Yes, but they're more complicated, I should say. First of all, you have to express cosine x as cosine 2x plus 1 divided by 2. Then cosine 2x times sine x, you have to write it as a sum of two single functions, but that just takes more time. This is the simplest way to do. Okay. The second, we always have an integral like similar to this. Right? It's a quotient, but the denominator, sometimes it's a little bit complicated, and sometimes just single function. Now, sometimes a linear, it will be like a square x plus 1, something like that. Okay, so that's where it become a bonus problem on the final exam. I will give you another example here, but I'm not going to show you in the class. You should do it by yourself. All right, so look at that. Don't use substitution. This can be easily expressed as sum of power functions. 5, 2 minus 1/2 is x3 over 2, plus 3, 1 minus 1/2 is 1/2, and 0 minus 1/2 is negative 1/2. Okay, so if you write down this, then you find the antiderivative of each. Okay, don't simplify at this point. And don't forget the constant c. Right, then you simplify it. I think it's 2x5 over 2, and this will be 2x3 over 2, and that is going to be 2 x to the 1/2 plus constant. This is. Now, what kind of problem would be more difficult? For example, if I ask you to do this one. All right, think about that when you get home. Okay, if you don't know how to do it, come ask me next class. The next problem. Find the absolute maximum and the minimum values of the function. And this is a function x plus 1 of x on the interval. Okay. Now, first of all, this function is defined on this interval. Okay. And it's continuous. So it must have a absolute maximum value, absolute minimum value. It's not easy to draw the graph. I'm not going to draw it. So what you have to do is, you recall the theorem, right? If the function has a local maximum value at some point inside the interval, that point must be critical number. Okay, so all you have to do is just look at the value of the function at the end points and at critical numbers in the intervals. Okay, because only those are the candidates of the points for the points at which the function has a maximum value or minimum value. So let's find the critical number. So it's 1 minus 1 over x squared when you differentiate. And if this set to be 0, and then x squared should be equal to 1, right? Then that means x should be equal to 1. Now, -1 is not in the interval, so I'm not going to mention that. So 1 is a critical number. Then you look at the value of the function, oops. Undo, right? Okay, I'm going to erase it. Not even moving. That's weird. Okay, go away. Almost. Yeah, I think there's a button on the pen. I accidentally click. All right. So we find, and then the next step is just find the value of the function at 2 points and that critical number. So this can be 1/2 plus -1/2. So it's 1/2 plus 2. That's 5/2. Okay, and then this 1 plus 1/1, which is 2, and 3. 3 plus 1/3. And this is the largest number, right? It's 10/3. Okay, so the absolute maximum value should be at the end point. Okay, so the question is find the absolute maximum value. So you should say that absolute maximum value is going to be 10/3. So that's clear enough. Okay. Then the absolute minimum value is f of 1. Yeah, f of 1, which is 2. Okay. That's it. Okay. Now we come to the volume problems. Okay. I want to set up the integral, sketches graph, set up an integral for the volume of a resulting solid. So the region, yeah, the region enclosed by the curve is located about the y-axis. By the curve y equals x squared minus 2x and y equals 0 is located about the y-axis. Okay, so we want, you have to sketch the graph, indicate those is sketch the graph. Okay, of this, the graph means a solid. Okay, and set up as the integral. set up any integral because there are several integrals there. So set up an integral for the volume. Okay. Now, a method is not specified. You can use disks, you can use cylindrical shells, but depends on the picture. Sometimes you can use either of them. Sometimes there's only one choice. Okay, much more difficult if you use the other one. So step one, draw the 2D graph. The curve, y equals x squared minus 2x. This is a parabola. So you can quickly draw the parabola because as you know, it has two intersection points. And 0, 1, right? It is opens downward. Okay? And the y equals 0 is the x-axis. So this is a graph. This is a graph, right? This is region we're talking about. I'm going to rotate about y-axis. So you draw another one similar, right? And then you make a circle, right? Okay, so that's the picture. What you can do, you can use the discs to cut this solid, slides by slides. So the cross section will be two circles, right? Inner circle, outer circle. The only problem is to determine the radius of these two circles in terms of y variable, because you use a horizontal. You use a horizontal. Use a horizontal plane to cut it. So the best method to solve this problem is use cylindrical shells. Okay, so this is a cylindrical shells. You draw the cylinder. Okay, here's the H, and that is R. The radius is R. Okay, so the volume, right on the volume formula, is going to be the integral 2 pi r h dr. So imagine the cylinder increases from the smallest one to the larger one, right? So r is going to be from 0 to 2. All right. So that is look at this formula. Okay, this integral with respect to the radius, and if you are able to express h in terms of r, you don't need to use the x variable. That doesn't matter, right? So here's a point. This is a special point on the curve, original curve, has coordinates x and y. So you need to write down what is the r here is the x. What is the h is the y. Okay, but h and y is related to x by the above formula. Okay, so it's better to use the x variable instead of a y variable. Okay, so you can, x is just equal to r, so no difference. So I can change r to x, and h is going to be y, but it's going to be x squared minus 2x, and the dx. Okay, so that's it. So this is a picture. If you draw the picture and does not take too much space. Okay. Now, if you use a y variable, this is it's impossible. I think you cannot solve for x. X is not uniquely determined the y variable. But if you want to use the disks to set up an integral, it's possible. But you have to find out the two radius. So let's try it. Just set up integral, so it doesn't matter, right? No matter how complicated the integral, you just get the integral, right? You don't need to evaluate. This is the idea, right? So here, you see, you have to draw a disk. There's in the disk, inside, right? Okay, so there is a disk, right? So this depends on the y value. Okay, so this is going to be A over y, is the area. So volume is the integral, A over y dy. But you have to determine the highest value for y, the highest point of the parabola. The highest point for the parabola is, I think it is clear, because the parabola is symmetric. So the vertex of parabola, the x value is 1. So the y value is going to be, wait a minute. Did I draw the picture right? This is when x, no, the value, y value, it's upside down. Yeah, when x value, you see, x equals 1. The y value is going to be, I should modify the problem, yeah. It's actually is a switch around, it's 2x minus x squared, okay? But this problem is x squared minus 2x, so it cannot change. Okay, then, yeah, I needed to make, yeah, what is the easiest way to, I don't want to destroy the picture, okay? So the easiest way to do is I modify the problem, just it's x 2x minus x squared, okay? So every, yeah, the change will be just this function. Okay, 2x minus x squared and x2 minus c. Before I plug in the number into the, I did not even see that. Okay, so this the picture is not changed. Yeah. Okay. Yeah, just the function. I changed the function. Just it's 2x minus x squared. Okay. All right, so here y equals 2 times 1 minus 1 squared equals 1. So that's the highest point. Okay, 1 is the highest point. Now the problem is we have to determine the radius. Right. For the given y, you have a 2x, x1, x2. So the radius, little radius, small radius is x1. The capital radius is a larger radius x2. So ay is going to be pi r squared minus little pi squared. So the question is how do you get x1, x2? How to express them in terms of y? Because those 2 points are on the curve. So this should be equal to y, then you solve for x. Okay, x squared minus 2x plus y equals 0. And you get 2 solutions for x. That is going to be 2 plus minus b squared 4 minus 4ac. All right. So after you simplify, it's going to be 1 plus minus 1 minus y. So my x1 is 1 minus square minus y. x2 is 1 plus. Okay. So 1 is large as 1 is small. So now I can put everything into the formula. Okay. Y is from 0 to 1. Pi capital R is 1 plus. Okay, and little is 1 minus square root 1 minus y and dy. Okay, yeah, think about that. How to get this, the picture. We find the radius of 2 radius for the given y value because you use the horizontal plane to cut the solid. And for the given y, you get 2 disks. But you use the parabola to determine x1, x2. And those are the radii of the 2 disks. Okay, so a little bit more complicated, but since we're not going to evaluate, so this is still okay. Right? But you can still evaluate it after you simplify. I think after you simplify, you will get twice of that, and actually it's 4 times. Okay. after you simplify, because plus minus square, that cancels out lots of terms. It's 2 and 4, yeah. So you can evaluate this integral. It's not too bad. Okay, you can use substitution to evaluate this integral. Right. So this is the question, and yes, you can see that if you use the disks to set up integral, it will be more complicated. Okay. My next question is, the region enclosed by the curve y equals 1 and the y equals x squared is rotated about the x-axis. Okay, set up an integral for the sketch the graph for the volume. Okay. I believe that we can use 2 different methods to set up 2 integrals. Okay. So since I have time, I'm going to do both of them. Okay. So this is a parabola, right? And this is the horizontal. All right. All right, so its rotation is about the x-axis. What you get is something like that. From all sides, looks like cylinder. So I want to see a picture like that. Now, if you use a disc to solve the problem, you have to draw the typical cross section. Okay, a typical cross section will be like this. Here's another circle inside, right? And this is the disk. So that's, and then the area will be AX because it depends on X. X is from -1 to positive. Okay, so use the disks, the volume is going to be integral from negative to positive 1, A of X dx. Right? The integral of the area cross section. All right, so what is A of X? A of X is is going to be pi cap, right? It's difference of 2 disks. Now I needed to know what is capital R, what is little r. I think from the picture here, this will be the capital R, right? The little r will be much smaller. That's the little r. So clearly the capital R is going to be 1, constant. But the little r is determined by the points on this curve, on this parabola, X and Y. So the little r is the height of that point, which is Y. But I have to express in terms of X because my integral is with respect to X. So it's going to be X squared. Right? Done. So here's the formula. I, 1 square minus pi, R squared is X squared and square dx. So that is the problem. Yeah. Okay. So this is a formula. This is integral for the volume. Now I'm going to use the cylindrical shells to solve the problem. Okay. So this time, I draw the cylinder inside. This is cylinder, right? Can you see that? So cylinder has a radius r and the h height. Okay, so the volume formula is going to be integral 2 pi r h dr. So what is the smallest value for r? 0. What is the largest possible value for r? 1. Okay, here's 1, right? Here's negative. Okay, because this is a curve y equals x squared. Okay, good. So let's, for the fixed r, I needed to, I think for the fixed y, I get a 2x values again, right? So this is a y value, y. So the radius is going to be y. And look at those 2 points, okay? This point I call the x2 and the y. That point is x1, y, because for the same y, I got 2 values, right? And the h should be x2 minus x1. Okay, because this is a point on the curve, so so x2 is going to be square y, x1 is negative square y. So that's why you get 2 square y. Okay, so then if you put them into the formula, I'm going to use a y variable, right? So y is from there, right? I is going to be y, h is going to 2 square y, and dy. Okay, so that's it. You will get the same value if you evaluate. Okay. Or you can, of course, you can still use I, and I is y is I, so it's no difference. You can use I variable. Okay. So almost for every problem, you can have 2 integrals for the volume. But read the question carefully. I didn't ask you to find the volume, and don't do that. Don't waste time. Okay. Number 7. A rectangular tank with a square base and open top has volume of 32 cubic meter units. Find the dimension that will minimize the surface area, including the bottom. Okay. So you draw the box. As this side is open top. Okay. Yeah. So the volume is given is 32 cubic units. Okay. Find it's a square base. Okay. Find the dimensions. That will minimize the surface area. Since I'm worried about you forget the bottom and top, so they're including the bottom. All right, so find the volume. All right. So dimension means height and edge length, right? So you can denote h, that will be A. Right, write down what we are given. We're given the volume. Volume is A square h, which is going to be 32. We're going to minimize the surface area. So surface area is the bottom plus 4 sides. A times h is the area of one side. They have 4 sides. The top one is not included. So the, the surface area depends on 2 variables. but those two variables are related by the volume. So you can replace one variable. I'm going to replace this one. It's easy to solve for h. So 32 over a squared, and I put into the second formula. Okay, so I get some function. It's like this. Okay, 4 times 32. I'm not going to multiply this out. That's good enough. All right. So this is a function in A, and if you draw the graph of this function, it looks like that. Okay, this is a capital A, this is little a. So it must have a absolute minimum value somewhere. Okay, we are going to minimize the surface area. And when A approaches 0 from positive side, it approaches infinity. When A approaches infinity, it also approaches infinity. So let me remark this. It's going to be infinity. This is A approaches positive infinity. Okay. So the graph looks like that. It must have the minimum, absolute minimum point. So I'm going to differentiate. Okay, I get 2a minus a squared 4 times 32. Okay, I set this to be 0. I multiply both sides by a squared, so it's 2a cubed. And then divide both sides by 2, it's 2 times 32. Now 2 times 32, think about it. 32 is 16 times 2. 16 is 4 squared times 2. So clearly it's 4 cubed, right? So that's why A equals 4. Right. So A equals 4. At that, when X 4, you get the minimum volume. Okay, so A equals is minimum at A equals 4. All right, this is not a dimension yet. We don't need to find the minimum surface area. Okay, we don't need to find the surface area. We just need to find the dimension. So when A equals 4, what is H? H is 32 over 4 squared. 32 a squared. 32 divided by 4 squared, 16. So that's going to be 2. Okay? So we find the dimension. When the top is open, and this should be looks like that. Okay, it's 4 and the 4 and the 2. So that this type. So if you build a tank, square type of a tank, right? If you go to some store to buy some material, then you want to hold as much water as possible with a, right? You know, you want to hold, say, you know how much water you have to hold, right? So volume is fixed. And you also know the shape of the tank is fixed, right? The square base, the top is open. And this is the dimension you have to follow. The edge length should be twice of the height. That's it. So this is a place where mathematics is used. Okay. If you just build one, it does not cost too much to change the shape. If you build thousands of them, right? Then that costs lots of material. Okay. So where's my picture? Okay. All right. Question number 8. So we are given the function sketch the graph. Okay, you have to find all necessary information. X over x minus 3. All right. So this is a rational function. It has it must have asymptotes. Okay. So here, yeah, look at the intersection point first. So we're going to draw the graph, right? So intercepts. Intercept is x equals 0, y equals 0. That's only one intercept. Okay. So don't worry about that. And then asymptotes. I think when x equals 3, that gives you the vertical one. Okay. And then you take the limit, y equals 1, that gives you the horizontal one. Y equals 1, the reason is the limit, yeah, you know, x equals 3 is it's obvious, okay? The graph, you know, blows up. So you can, you know, when it's plus, and x approaches 3 from positive side, right? This can be positive infinity, right? When x approaches 3 from negative side, you get a negative infinity. Okay, that's the reason you get a vertical asymptotes. When x approaches plus minus infinity, any direction, that is going to be 1. Why it's going to be 1? You can divide the numerator and denominator by x, and clearly 3 of x approaches 0. So it's going to be 1 over 1. Okay. All right, so we get asymptotes. Now, how can I draw the graph? I want to draw the graph first before I do the computation. All right. To draw the graph, I needed to look at the picture nearby x equals 3. Okay. Nearby x equals 3, y equals f of x, right? That's x minus 3. It's almost equals 3 over x minus 3. It's constant. So I know the graph of a constant divided by x minus 3. So the graph will be like that. Okay. This is 3. This is a graph for y equals 3 over x minus 3. Okay. So our graph should be similar to that. Okay. Therefore, I can sketch the graph right now. Okay. This is a x-axis. This is y-axis. So 1, 2, 3. This is line 3. Okay. And I also have a horizontal line. This is y equals 1. Okay, so the nearby the vertical lines, this graph looks like the one on the right-hand side, right? So it is clear to me I should draw the graph like that, and it intersection this point, so it's clearly must be like that. Okay, because this is the intersection point. Okay, step. So from this graph, before you even find the derivative, I can tell that the derivative here is negative, and here also negative, and here concave up, and this side concave down. Okay, and no points of inflection. Right? Yeah. So decrease interval of decreasing, I can tell you that the function f of x is decreasing on the interval from negative infinity to 3 and from 3 to positive infinity. Okay. Concave down, and from negative infinity to 3, concave up, from positive 3 to infinity. Okay. All right. So that's it. To verify this using the derivative, you can find the derivative, right? So look at the derivative. Yeah, here's the derivative must be negative, and here's the derivative must be positive. Here's the derivative is always negative. Right, so I'm going to check that. Y prime is x minus 3 square. and the 1 times x minus 3 minus x times 1, which is going to be negative 3x minus 3 squared. It's always negative. That verifies our statement. Okay, the second derivative, have to be a little bit careful. This is going to be negative 3. X minus 3 to the negative 2, right, the derivative. So I get a negative, negative becomes positive. It's a 6, x minus 3 to negative 3. So this one changes signs when x equals 3. Okay, so y primary, you can see that it's going to be negative if x is less than 3, positive if x greater than 3. Okay, so that is means can carry down. And can carry up. Okay, so you can use the derivatives to verify what I see. And for this graph, and I don't need it to find the derivative either. Okay. And at incremental is 1 meter long, 1/2 meter wide, and 1 meter deep. So we have a tank, water tank. Okay. So here's a 1 meter long and 1/2 meter wide and 1 meter deep. Find what needed to pump half of the water out of the tank. You are expected to find the Riemann sums first as an approximation of the integral. Okay, you cannot just write on the formula from nowhere. You have to derive the formula, right? So we're going to empty half of the water. Okay. Okay, so this is eventually good. That's what. Okay, this is a picture. All right, so we have basically we just have to lift half of the tank of the water, you know, out of the tank, right? So the draw, you have to find the way to set up the integral. Okay, so you can use doesn't matter, you know, the integral will be slightly different. Okay, the result will be the same. Depends on how do you choose the coordinate line. Okay, you can choose a coordinate line from here, from the bottom. Okay, so that is my coordinate line called x. Okay, so this will be 1/2. Here's 1. That's be 0. Okay, if you choose that, then if you choose this, then you can divide the interval into many slides, right? Okay, so delta x is going to be 1 minus 1/2, right, divided by n. Okay, so it is going to be 1/2n. That's okay. So you have xi equals 1/2 plus I delta x. So let's take a look at the one slide. How heavy is the one slide? Okay. Yeah. So the volume of that one slide, it's going to be the width is 1/2, the length is 1, the thickness is delta x. Okay. Okay. So how much? Yeah, this will be the xi, right? Okay. So that slides, that's the volume. If you want to know how heavy it is, you have to multiply it by as a density rho, Vi, right? Okay. So you have to multiply Vi, the rho, right? Yes, the rho is going to be 1,000 kilograms per cubic meters. Okay. So you need this much force to lift this one slide to the top of the tank. The distance it travels is going to be, that's the force, right? It will be 1 minus xi. Okay, so the work done to lift that slide to the top, just like a think about this a solid, okay, it's not liquid. It's going to be about Fi times di, the distance it travels and times the force. So total force is going to be sigma ni from 1 to the I, and that is going to be estimate, yeah. F times di, okay? So let's write down the F. The rho, the volume is 1/2 times 1 times delta x, and the d is 1 minus xi, okay? Now, if rho is a constant, right? So 1,000. Now, if you take the limit, okay, W is going to be the limit as n approaches infinity. This is going to be the integral of, its integral x is from 1/2 to 1. And here's 1,000. And the 1 minus x, delta x become dx. Right, so this is going to be the integral of the for the work to be done. Okay, so it's 1,000, it's a 5,000. Okay, and then use the antiderivative. This can be 500. Okay, antiderivative this function is x minus half of x squared, and evaluate at 200 points. Okay. You can use a substitution to, I think a substitution would be better to simplify the notation. Otherwise you have to do lots of computation here. The substitution is you let u to be 1 minus x, right? So it's 500. When x equals to 1/2, that's 1/2. When x equals 0, and this u and the negative du, right? So that's turned upside down. So the antiderivative of this will be half of u squared. And I will get, okay. So 500 divided by 8. 500 divided by 8, I don't know. You can do that, okay? 500 divided by 8. Divided by 8, right? No. So 62 point. All right, so that is the answer, okay? And the units will be kg and the meat. Can create any unit. So the last problem I want to discuss is going to be, again, the graphing problem, okay? F of x, because there are three types of functions. One is a polynomial, other one is involve radicals, and then also rational function. You should know how to sketch the graph of each of them. Okay, so this is a function, okay? Sketch the graph. But you also have to find all the necessary information. Okay. So look at this graph. What is domain? Okay. So domain is going to be x is less than or equal to, right? Because it's inside radical. Okay. And you know that when x equals 0, y is going to be 0. When x equals plus minus 2, y is also 0. So the graph touches the, yeah, those called the intersection points, maybe? Intercepts, yeah. All right, there's no horizontal, no asymptotes. Okay, so this is a graph. Okay, the graph, the function is non-negative, right? The graph is always above the axis. Here's 2, here's -2. So it should be go up and down and then go up and down, okay? So I needed to determine two highest points on the graph. No, this is when x, yeah, x is going to be negative on this side. Yeah, be careful. Yeah, x is negative, not down. So this is a graph, okay? At two endpoints, the value is going to be 0. I needed to know where the, yeah, I have to find out where the graph is increasing, where the graph is decreasing, and the maximum point, the minimum point, right? I also needed to know the point, inflection point, okay? So we almost know the graph already. This graph looks like that, okay? I needed to find the critical numbers. So here's f of x times 4 minus x squared to the 1/2. Find the derivative. It's 1 times 4 minus x squared plus x 1/2 4 minus x squared to the -1/2 -2x. Okay, so simplified, I will get, now this is a positive here, that's negative. So I get 4 minus x squared, and when it's going to be negative, x squared, 4 minus x squared. So how to solve this equation? All right. To solve this equation, you have to multiply both sides by 4 minus by this term. Okay. So you get 4 minus x squared minus x squared is going to be 0. And 4 minus 2x squared equals 0. X squared equals 2. And that implies x plus minus square root 2. So you do have those two numbers. Those are two critical numbers. And the y value is going to be, when x equals square root 2, the y value is going to be square root 2 4 minus x squared is 2. I think that is going to be 2. Okay? When x equals negative square root 2, the y value is going to be negative square root 2. 4 minus 2 to the 1/2. It's going to be negative. So this gives you the lowest point and the highest point. So you should draw the picture here. Yeah, you put it here and square root 2. And this is another point. All right. So from the graph, it's clear that where the graph is increasing, where the graph is decreasing. But if you modify the derivative here, like a 4 minus x squared to the negative half, then you can 2 minus 4 minus x squared, so 2 minus square. Then you can clearly tell where is the graph, where the derivative is positive, where the derivative is negative. Okay, so it's clear that when the derivative is negative. Okay, so the derivative is negative when x squared is larger than 2. Okay, it's going to be negative if x squared greater than 2. Okay, x squared greater than 2 means x is less than negative 2 or x greater than 2. So there are 3 intervals there. On the left side, it's decreasing. On the right-hand side, it's decreasing. In the middle, it's increasing. Okay. So I can say that f increasing on the interval from negative 2 to positive 2. Wait a minute, just square root 2. Yeah, square root 2. Okay. The function is decreasing on the interval from negative 2 on these 3 intervals. So I have to know the second derivative in order to determine the fraction points, where concave up or where concave down. So that's a little bit difficult to find the second derivative, right? Well, use the first derivative. The second derivative is going to be the derivative, the first derivative. Okay, I can use a simplified version or the original one. I'm going to use a simplified version. So the derivative of the first term is going to be 4 minus x squared negative 3 over 2 and times negative 2x. Okay, then the derivative of the second term is going to be negative 2x. Okay, we have to simplify it. So these 2 cancel out. I got positive here, right? 4 minus x squared to negative 3 over 2 x. Okay. And the second term is actually negative. It's 2x. So I should take something out. I think the term was listed, the lowest power should be taken out. And also should take out the x because x is a common factor. I can keep it, right? Then 4 minus x squared negative 3 over 2 and x 2 minus x squared minus 2x When you take this out, I have a 4 minus x squared. All right. So I get, yeah, if we take x out, yeah, let's put the x here, okay? Then I have a 2 minus x squared minus 8 plus 2x squared. So after simplified, I will get x squared minus 6. Wow, what happens? Let's go back to the picture. Looks like we have a, we are going to have a, no, this is okay. So x squared minus 4 minus, yeah. Okay. So if I take the sign out, I get a negative 4 minus x squared, negative 3 over 2, x 6 minus x squared. Remember, this is always a positive because we are on the interval from negative, from 2 to positive 2 on this interval. Okay, so this is always negative. And the 4 minus x squared is always positive. Yeah, this is positive, this is a positive. The sign is only determined by x. So clearly the second derivative is going to be positive if x is negative, and the second derivative is negative if x is positive. So concave up on the negative x side, concave up. Concave it down on the right-hand side. And look at the picture again. It's a way we should know already from the picture, concave up, concave it down. Okay, so I think you should draw the picture first before you do any computation. Okay. The second derivative here is in the positive, the second derivative here is negative. And from the graph, it's easy to see. So the inflection point is the origin. Okay, origin is the inflection point. The computation is not trivial. You have to be very careful when you simplify. Okay, so the inflection point is the origin. Okay. But we should know that at the very beginning, right? We look at the picture, we already see the picture, and it must concave up on the left-hand side, concave down on the right-hand side. We just use the derivatives to verify this. Okay. So when you get home,